Hey there, ladies and gentlemen, boys and girls. Welcome back. Today we're going to be starting our first conversation talking about energy. Right now, energy is a tough one. Energy is a tough one because, as you saw probably from the video, like we all know it's very, very important, and we know it's everywhere. And there's parts of it probably from school that you've learned about before, and yet it's extremely complicated, but yet extremely simple, basic but complex. It's everywhere but can't be seen. It's a tough topic to describe, and so we're going to just go with real basics here today. We're going to just talk about some real basic stuff, and a lot of this is going to be review. Although I'll probably be adding a couple extra things just to maybe from the mind frame, because I know in middle school you guys deal a lot with energy, but here we're going to talk a little bit more than just mechanical energy, which is what most of the middle school you guys probably built a roller coaster and talked about potential energy. I'm going to go a little broader than that. So let's start with the very beginning. All right. Obviously, energy is throughout this universe. We don't see it. It's transported around the universe from place to place using waves, either electromagnetic waves or sound waves, which are mechanical waves. No matter what happens to that energy is though conserved. And this is one that we are all pretty much familiar with. Our first term that we're going to talk about here, which is that law of conservation of energy, right? Law of conservation of energy. Although similar to the one of mass, this law basically states that all the energy in the universe is conserved. Energy cannot be created nor destroyed, but it definitely, absolutely, 100% can be changed. All right. In how we name different parts of energy, from say chemical energy to mechanical energy to electrical energy to sound energy, it's all energy. It's all energy. And so I typically abbreviate energy with just a big E. All right. But it's all energy, but it's just about what that energy does is what gives it different names. We as humans have named certain things sound energy because of how it impacts our ears and thus our brain and how we perceive the world. It's not really that much different than, kinetic energy or, thermal energy or nuclear energy. It's just about how it impacts different things. And so we give them different names. So we know the law of conservation of energy can't be created nor destroyed, but it can be changed or transferred. And that is very, very, very important to understand that energy can be transferred. And there's actually, again, we're putting names to all of this very, very, very big concept as humans. We're putting names to these. There's really two names of all kinds of energy that we do, the two kinds. There's potential and kinetic, and it's not necessarily the type of potential and kinetic energy you're thinking about when you thought about building roller coasters that you probably did in middle school or something like that, where you race cars and you're measuring how fast they would go. That's actually a very specific type of potential and kinetic energy. Potential and kinetic energy are two different things. Let's start with a simpler one. Let's start with kinetic energy. All right, kinetic energy is just the energy of motion. All right, kinetic energy. It's very, very big. Anything that's in motion. Now that can go everything from a giant, boat moving to the idea that the continents are moving to the idea that the planets are moving, all the way down to the very smallest things and talking about atoms and electrons circling the atom. That electron has kinetic energy. All right. So kinetic energy is anything that has to do with motion. And if you think of kinetic energy, you should be thinking of the word motion. All right. But where does that energy come from? How does an object become faster? All right. There's a couple ways that can happen. It can either be a transfer of energy from one object to another, smashing into it, or something else, the other part of this, which is what we call potential energy. Now, I'm going to go over a couple examples of potential energy, but this one's a little bit trickier. All right, potential energy is a little trickier. All right, so first let's break down that word potential. All right, I always like to think about it in terms since I like sports, I like to think of it when they talk about an athlete. We have the NFL football draft coming up soon, and so talking about potential energy, we talk about players who have potential. Chase Young from Ohio State is going to be one of the top picks in the draft because he has enormous potential. And what does that mean, potential? He has enormous potential. What do we mean by that? We mean that he has talent that's not there yet but could be. It's what will become his talent, right? Or his ability to tackle or get sacks in the NFL. Potential energy is energy that could be kinetic energy. All right. So, for example, let's do a couple quick examples of different types of potential energy. All right. And so, some of the ones you probably have heard of before. All right. So, let me here we go. I have my ball here. All right. I have a little red ball. All right. I'm going to set it on my. Let's see if we can do it right. Let's see. We'll do it right here. If I set it on the table right here. All right. So if we talk about its energy right now, let's talk about its kinetic energy. So right now, this ball does not have any kinetic energy. Now, we could talk about the actual individual atoms on there of the kinetic energy of those molecules. Let's not get there that far yet. Let's slow down a little bit. Let's take it far out. Let's look at the ball as a whole, the system as a whole. All right, the ball has no kinetic energy. It is not moving. All right. Now, if I were to lift it off the table, right now, as I'm holding it, it has no kinetic energy. But what I did do is provided the opportunity to go into motion. Because when I let go of it, the ball is going to drop due to gravity. Gravity is going to pull it down. And so now it has the potential to go into motion. Right? The opportunity, it could, now it has energy, almost what they sometimes will say, it's stored in there. All right. It's not like a cup. It's not actually storing in there, but it's a terminology we like to use, that there's energy stored in there that it's could become kinetic energy. Because right now it has none. It's not moving. But the moment I let go, it starts to move. Where did that energy come from? It can't be created. No, it is energy that I've provided potential energy to the ball so that it has the potential to turn it into kinetic energy. Right now, where that potential energy come from? It came from me. So then we'll eventually talk about transferring energy. All right. Now, this is what we call gravitational potential energy. And it's called gravitational potential energy because I gave it the potential to move because of gravity. If I held it up like this and we were outer space and I let go, where gravitational pull is not very big or at all, it's not going to fall. It's not going to go into motion. So this is gravitational potential energy. Now that's based on how much I move it. So if I lift it up a little bit higher, I'm adding more gravitational potential energy to it, and it could move even more kinetic energy. I provided more energy that could become kinetic energy. All right, so that's the one you guys are probably all very, very familiar with. In fact, most of the time when I talk about what's potential energy, people will say height. It's like, well, that's a part of gravitational potential energy. Another very basic one is rubber bands. All right, so I have a rubber band right here, right? Again, we're not going to talk about the individual atoms just yet. We're just going to talk about the rubber band itself. All right, and if I just kind of hang it like this, all right, I know it's wiggling a little bit, but basically it is not moving. It has zero kinetic energy. It is not moving, but it has a little bit of potential and it's off the ground, but let's focus on just the actual rubber band right now. All right. But if I were to stretch it, all right, and now I'm holding it right here. Right now it has zero kinetic energy because it's still not moving. But if I were to let go, it snaps and we see that it go into motion and now it has kinetic energy. I've transferred potential energy into kinetic energy. Well, where did that kinetic energy come from? You say, well, it came from me, but I'm not like slapping it. What I'm doing is when I pull it apart, I'm putting in stored stored elastic potential energy. I'm giving it energy based on its principles of or how elastic it is, how able to stretch out. The more potential energy I put into it, the more it can move. The less potential energy I put into it, I'm storing some of my energy into it, the less it's going to move. So potential energy is just this idea of energy stored somewhere that could be used for some sort of kinetic energy. All right, so now let's go into one that you guys do with every day. In fact, you might be doing it right now as you watch this video, and that is eating. All right, we get our food, we get our energy from food. So this is my little chocolate bar for my breakfast here. All right, as I eat this is made up of hundreds of different chemicals, millions of atoms that are bonded together. All right, those bonds, covalent ionic bonds, have stored energy in them. And so what my body is going to do, I love chocolate. What my body is going to do when I eat it is it's going to break apart those bonds, those covalent ionic bonds. When it does that, it is going to release energy in the form of heat energy. Heat energy is literally just kinetic energy of particles, small molecules, atoms. All right, and that energy is going to be used by my cells to do all the things cells need to do to survive, and thus for me to survive. All right, we actually even have a very specific measurement for the amount of stored chemical potential energy in those bonds that we have, and it's called the calorie. A calorie is actually a very large measurement that we use to measure chemical stored energy. The potential energy in these chemical bonds that could be used to make my cells move and the molecules of my cells move and heat up and do the things they need to do. Now, both of these, the calorie is the one we use for food and stored chemical energy, but it's not actually the primary unit we use for, I'm hungry, unit for energy. The primary unit we use for energy, let me move me over here. All right, is a unit that was discovered by that was by a mathematician and a scientist and physicist. I'm drawing. These are all types of potential energy, whether it's chemical, there's nuclear, there's elastic, there's all kinds of different gravitational, all right? Or whether it's kinetic energy, whether it's electrical energy or mechanical energy, that's like moving a car and stuff like that. That's mechanical or kinetic energy. They are all measured with the same unit called the joule, all right, which we abbreviate with a capital J. All right, the joule is the main unit that we use for our energy, and we can convert that number of joules to equal 1 calorie because these have a lot of energy. A joule is not that much energy. Take about a good pen and lift it about 2 feet in the air. You used about a joule of energy to do that. That's not that much. All right. So when we talk about running our entire bodies, we use a larger system called the calorie. All right. So law of conservation of energy. Energy can't be created or destroyed. That energy is, though, constantly transferred between different types of potential energy and kinetic energy. Kinetic energy is the energy of motion, whether we're talking about an electron, we're talking about galaxies moving around each other. Those all have kinetic energy. They get a lot of that energy either from transferring from other objects or from what we call potential energy. It's energy that can be kinetic energy. All right. And there's all different kinds. And we'll talk a little bit more about the different kinds as we go forward. So that was just my little introduction about the different type, what is energy, potential, and kinetic as we go forward. So make sure you go back if you didn't feel like you wrote anything down on these notes here. Go back and add to your notebook on this. Otherwise, thanks for watching. And good luck, and may the science be with you.